Hello listeners and viewers, welcome to Kaduna State Ministry of Education Radio and TV e-learning program designed for our SS3 and other students staying at home due to the coronavirus pandemic. The present administration under the able leadership of His Excellency, Malam Nasir Ahmed El-Rufai, is positioned as always to ensure that under his leadership, our students are not left behind in all areas of human endeavors, especially education. Kaduna State is the center of learning. Therefore, we want to ensure that our students excel in their forthcoming examinations and beyond. Students and other learners at home are given this opportunity in order to continue learning, as education is a continuous process. Different subjects will be taught in this program to assist students to perform excellently in the forthcoming Senior School Certificate examination being conducted by NECO and WAEC as soon as schools reopen. Teachers making presentations will always provide their names and phone numbers during each presentation, and they can be contacted for questions, further explanations, and/or clarifications. The following numbers and contacts can also be reached for expression of any concern or observation: 090-865-00545 or 080-383-62072. Our website is www.education.kdsg.gov.ng. Our email education@kdsg.gov.ng or education.kdsg@gmail.com. Our YouTube channel, Ministry of Education, Kaduna State. Our Twitter handle @Kaduna_MOE. Or our Facebook page, Ministry of Education, Kaduna State. Stay safe, stay at home, and learn well. Thank you, happy listening, and happy viewing.
Hello and welcome, my wonderful students. I'm happy to be here again to take you on chemistry. Today, my topic will be on redox reaction. I'll be building on our previous lesson, electrolysis. Redox reaction, we are going to take it under the following contents: introduction, definition of terms, and the terms are oxidation, reduction, oxidizing agent, reducing agent, oxidation number. We will be looking at how you can test for oxidizing agent and reducing agent. Then we will calculate oxidation number, teach you how to give IUPAC nomenclature of inorganic compounds, and of course, steps you can follow to balance a redox reaction. My science students, you wonder sometimes when somebody say tetraoxosulfate 6 acid or trioxonitrate 5 acid, or somebody says iron 3 tetraoxosulfate 6. Today, if you follow me, you will know how you can name these compounds with ease. And that is the essence of today's lesson. And like you can see, redox reaction is the abbreviation of reduction and oxidation. Red is reduction, ox is oxidation, as you can see clearly displayed here. In our day-to-day activities, we observe or we see a redox reaction taking place. These reactions take place simultaneously. We have seen them occur at our cathode and anode during electrolysis. Redox reaction occur in an everyday activity such as rusting of iron. When you expose iron, maybe roofing sheet, after some times, it turns from a shiny surface to a reddish brown coloration. Now others are sanitizing water, bleaching materials, photosynthesis, just to mention but a few. Now, we are going to look at the next content, which is definition of term. You can see that oxidation and reduction can be defined using parameters. The first parameter is in terms of oxygen and hydrogen. In terms of oxygen and hydrogen, we say oxidation is the addition of oxygen and the removal of hydrogen. Oxidation is the addition of oxygen and removal of hydrogen. Now, reduction is the opposite of oxidation, such that you can say reduction is the removal of oxygen and the addition of hydrogen. Reduction is the removal of oxygen and addition of hydrogen. Now, if you look at the simple equation there, from my far left, you have CH3, CH2OH. That is called ethanol in chemistry. And from ethanol to ethanol is another one. The next one is called ethanol. If you look at the ethanol, there are 6 hydrogens, but in ethanol, there are only 4 hydrogens. It means that hydrogen has been removed. And by our definition, it's an oxidation process. And from ethanol to ethanoic acid, you can see that 1 oxygen has been added. Instead of 1 there, you have 2 here. This is what happens when you make your kunu. It's very sweet. But when you expose it to air, after a day, it turns sour. Sour is a characteristic of an acid. So it's called oxidation of primary alkanol. From ethanol to ethanoic acid. That has shown oxidation on the top arrow and reduction in the backward arrow, because this reaction is reversible. It means it can proceed forward and backward simultaneously. The next definition is in terms of electron transfer. In terms of electron transfer, oxidation is the loss of electron and reduction is the gain of electron. Oxidation is the loss of electron and reduction is the gain of electron. I tag oxidation as oil, O-I-L. Oxidation is loss. And I tag reduction as rig, R-I-G. Reduction is gain. Now, if you look at the equation here, you will have seen these processes happening. You will see that in the first equation, hydrogen there has oxidation number of 0. And if it goes to hydrogen in hydrochloric acid, it has oxidation number of +1. So you can see, so also you can see it there, ion 2 to ion 3 by the loss of electron. And if you can see it in an equation, ion 2 chloride plus chlorine to give you ion 3 chloride. It has been shown here that oxidation is the loss of electron, and here it has been shown that reduction is also the gain of electron. The last definition is in terms of oxidation number. Oxidation is the increase in oxidation number, and reduction is the decrease in oxidation number. Oxidation is the increase in oxidation number. Reduction is the decrease in oxidation number. As you can see clearly, from 0 to +1 is an increase. From +2 to +3 is an increase. But if you look at the reduction side, you see that chlorine is 0 to chloride, which is -1. When it is a molecule, Cl2, it is called chlorine. But when it combines with hydrogen to form hydrogen chloride, it becomes chloride. So chlorine is 0, chloride is -1. And from 0 to -1 is a decrease in oxidation number. Another concept that will interest you is the reducing agent known as reductant and oxidizing agent known as oxidant. In English, an agent is a causative, something that causes another thing to happen. So that if we say reducing agent, we are referring to these substances that causes reduction. And they cause reduction by losing electron. If they don't lose electron, the reduction process cannot gain electron. So we refer to them as electron donating, or donating electron, or electron donor. They are oxidized in the process. It's important that you know that they are oxidized in the process. Some very common reducing agents are coke, which is carbon 2 oxide, CO, hydrogen sulfide, sulfur 4 oxide, just to mention but a few. The oxidizing agent, on the other hand, causes oxidation to take place. And they can only cause oxidation to take place if they gain electron lost by the oxidation process. So they are called electron acceptors. And they are reduced in the process. Remember, they are reduced in the process. Some very common oxidizing agents are potassium tetraoxomanganate 7. Potassium tetraoxomanganate 7. Then we have potassium heptaoxodichromate 6. Then we have chlorine, oxygen, hydrogen peroxide, concentrated trioxonitrate 5 acid, and hot concentrated tetraoxosulfate 6 acid. These are very common oxidizing agents that you see in the laboratory. The essence is that in an examination, you can be asked to list some common oxidizing agents. Now, in this reaction, sometimes in exam, you are asked to identify the oxidizing agent or the reducing agent. Now, using this equation, you find out that we have our sodium thiosulfate reacting with iodine. And if you look at the equation, you find out that iodine is having oxidation number of 0. Why? Because it is in an uncombined state, having the same number of proton and electron. But when it combines with sodium, it becomes -1. So from +1 to -1, there is a plus. From 0 to -1, there is a decrease in oxidation number. That is reduction. And because it is reduction, it is the oxidizing agent. And of course, the thiosulfate becomes the reducing agent. The second equation is when you react hydrogen sulfide with iron 3 chloride, sulfur will be deposited. So if you look at sulfur, there has oxidation number of 0. But if you look at hydrogen in hydrogen sulfide, the oxidation number is +1. So from +1 to 0, there is an increase. So that is the oxidation process. And because it's the oxidation process, it becomes the reducing agent. Then your iron 3 chloride becomes the oxidizing agent. My wonderful students, with this little explanation, I hope that when you come across a question of similar integrity, you'll be able to attempt it and you score it correctly. Let's move. Further as we look at a summary of the definition I have told you earlier on. It will help you to remember this definition easily and they will be at the tip of your fingers. The first one is oxidation gained oxygen while reduction lost oxygen. Oxidation lost hydrogen while reduction gained hydrogen. Oxidation is the loss of electron while reduction is the gain of electron. And oxidation is increase in oxidation number while reduction is decrease in oxidation number. When we hit this, we want you to get it at the tip of your fingers. And that is why we summarize oxidation definition as oil. Oxidation is lost. Rig. Reduction is gain. Of course, remember that both processes has to do with your E-, which is the electron. My students, I hope you are catching fun and enjoying yourself while we are interacting in chemistry. Now, these processes, you can identify an oxidizing agent and also you can identify a reducing agent. Now, these are the tests for oxidizing agent. The first one is that any substance that you react with hydrogen sulfide and it deposits sulfur is an oxidizing agent. While any substance that when you react with potassium tetraoxomanganate 7 and the purple color changes to colorless is a reducing agent. Remember I said any substance that you test using acidified potassium tetraoxomanganate 7 and the purple color of the potassium tetraoxomanganate 7 turn colorless is an example of a reducing agent. There are several other tests that you can apply to test for oxidizing agent or reducing agent. Now let's look at oxidation number or oxidation state. Very, very important. It is called oxidation state, and oxidation number is defined as the charge which an atom appears to have, ion or radical. Now, when an ion or radical carries a charge, that charge is known as the oxidation number. And there are rules that you follow to assign this oxidation number. The first one is that oxidation of every element in its free or uncombined state, when it has not combined with any other element, is 0. And the reason is because number of proton is always equal to number of electron. Protons are positive, electrons are negative. So plus minus is equals to 0. Then of course I say the oxidation number of hydrogen in all compounds except hydride is equals to +1. Now when you say a hydride, it means that hydrogen becomes electronegative. You can see that hydrogen is on the left-hand side, like sodium hydride, calcium hydride. In that case, hydrogen has oxidation number of -1. Oxygen in all compounds except peroxide has oxidation number of -2. You can see that a peroxide carries the formula. You can see it H2O2 or Na2O2. That's the formula of peroxide. So hydrogen peroxide, sodium peroxide, oxygen exhibit oxidation number of -1. Then we say that the oxidation number of group 1, 2, and 3 elements, they are metals, so they have +1, +2, and +3 oxidation number respectively. Remember I said group 1, group 2, and group 3 elements have metals, so they carry oxidation number of +1, +2, and +3 respectively. Then the halogens, the group 7 elements, they are tending towards stability, so they have oxidation number of -1, meaning that they need 1 electron to attain their octet configuration. Now, after we have continuation of the rules, you say the sum of oxidation number of a polyatomic ion. That means when you have more than one ion, one atom in a compound, in a radical, it carries a charge, and that charge is equal to the net charge of the ion. So you can see that in that case, OH has -1, tetraosulfate 6 has -2, and we say lastly, the oxidation number of all atoms in neutral compound is 0. The convention is that cations are written first in the formula followed by anion. E.g., hydrogen is the cation, which is hydrochloric acid, and chloride is the anions. So we'll take some very common examples. But before then, let's look at the uses of oxidation number. The number 1 use of oxidation number is that it is used to give IUPAC nomenclature to inorganic compounds. Then the second one is that it is used to know which species has been oxidized or reduced, as has been portrayed in the definition earlier on. So we'll look at example. Example number 1. Calculate the oxidation number of manganese in potassium tetraoxomanganate 7. You can see potassium, manganese, oxygen is 4, that's why we're multiplying by 4, and everything is equal to 0 because it's a neutral molecule. So that potassium belongs to group 1, that's why it is +1. Then manganese is the unknown. Oxygen has oxidation number of -2, and there are 4 oxygens. So when you multiply -2 by 4, you have -8. So mathematically, you find out that you have -8 + 1 equals to 0 when you collect like times. And when you collect like times, you find out that manganese has oxidation number of +7. And that is why you will name this compound as it has been named earlier. I will give you the methodology. When you are naming a compound that have more than 2 atoms in that compound, you will start from your left, you come to your right, and you finish with the middle element with the oxidation number of the middle element. So I'll take it again. You start from your left, you come to the right, you give the name of the element in the middle and the oxidation number of the element. In that case, we can say potassium tetraoxomanganate 7. Potassium tetraoxomanganate 7. The next example is slightly different from the one we have seen earlier. The reason being that we are using an ion or a radical that carries a charge. Look at what the question says. Calculate the oxidation number of chlorine in trioxochlorate 5 ion. The negative sign there shows that it's an ion. So of course you can see that chlorine plus oxygen times 3 is equals to -1. That -1 is because of the charge the ion is carrying. So if you evaluate it, you see chlorine has oxidation number of -2. So chlorine -2 times 3 is equals to -1. Then of course you have it to be -6 is equals to -1. If -6 crosses the equality sign, it becomes +6. So +6 minus 1 is equals to +5. And that is why you see that the compound become trioxochlorate 5. Remember I said if there are more than 2 atoms in that molecule, you start from your left. But the sign there shows that one atom has been removed. That's why you have the minus sign. So I started from my right, which is trioxochlorate 5 ion. Now, I have more examples to give you, but I would like to go to the one that is very, very interesting. Oftentimes, our students hear the name of a compound like carbon 4 oxide. Now, they see, where is the 4 coming from? This formula is CO2. Where is the 4? Why is it called carbon 4 oxide? And there is no 4 in the formula. Now, the 4 there is the oxidation number of carbon. And how do we get the 4? We get the 4 by these two arithmetics. Carbon plus oxygen times 2. Why are we multiplying by 2? Because there is 2 in the formula. And it's equals to 0 because it's a neutral molecule. So if you evaluate it, you have oxygen as minus 2 times 2 equals to 0. So minus 2 times 2 is equals to minus 4. So when minus 4 crosses the equality sign, it becomes plus 4. And because the oxidation number of carbon is 4, that is why it is called carbon 4 oxide. In areas where the oxidation number of carbon is plus 2, is called carbon 2 oxide. My wonderful students, the lesson has been so interesting. I wish that we can continue, but time is not on our side. Stay safe, stay at home, study your books, and prepare for your examination. As I welcome my noble colleague, Malan Ibrahim Umar, to summarize and give you the assignment for today's lesson. Have a wonderful day.
Good day, my wonderful students. Well done, Mr. Philip, for this wonderful presentation. Nevertheless, I want to take a few time in order to summarize what he has said for easier understanding. 1. The definition of oxidation, reduction, oxidizing, and reducing agents. I want you to know that oxidation can be defined as 1. Addition of oxygen. 2. Removal of hydrogen. 3. Loss of electron. 4. Increase in oxidation number. Then reduction is the complete opposite of oxidation. That means I can define reduction in 1. Removal of oxygen. 2. Addition of hydrogen. 3. Gain of electron. And finally, loss in oxidation or decrease in oxidation number. Also, now oxidizing and reducing agents is another, they are very important concepts. Now, what is an oxidizing agent? Oxidizing agent is the species from the reactant that is being reduced, while reducing agent is the species that from the reactant, very important, that is being oxidized. Good. Then when we go to test for oxidizing agent, he made mention that to test for oxidizing agent or common oxidizing agents include carbon in form of coke. We have the carbon 2 oxide and so on, while the popular reducing agents include potassium tetraoxomanganese 4 and potassium heptaoxodichromate 6. Having said that, I'll go quickly to calculation of oxidation number or naming of compound, which is very important. When you are able to calculate the oxidation number, which he did justice to, he gave you the items, itemize them step by step. After you calculate, it is important, I will repeat what he said. When you have a compound that you are naming, you start from the left, you go to the right, you end from the middle, and then the oxidation number of that middle compound will be stated clearly. Very important, as my Oga used to say, Mr. Philip. You start from the left, you go to the right, you end from the middle, and then you give the oxidation number of the element in the middle. Having said that, I will go to the assignment quickly because time is not on our side. Now, these are the assignments that you are expected to sit at home and do. Question 1. In terms of electron transfer, define A, oxidation, B, reduction. Question 2. Determine the oxidation number of manganese in MnO4 minus. I'll take it over again. Determine the oxidation number of manganese in MnO4. It is an ion, so it has a charge of minus. Then 2b, state 2 uses of oxidation number. State 2 uses of oxidation number. Question 3a, list 2 gaseous reducing agents. Give 2 examples of reducing agents that are gases. That means list 2 gaseous reducing agents. And B, write 1 equation each to illustrate the reducing property of the gas listed in 3a above. Thank you very much for listening. In case you solve the question or you have any observation, questions, or any suggestion, you can contact us using our numbers. 1. Mr. Philip Mamman with phone number 080-26-59-8861. I'll take the number again. 080-26-59-8861. Then Ibrahim Omar 070-3620-2842. I'll take it again. Ibrahim Omar is 070-3620-2842. And Mr. Williams Ishakun 081-606-70920. 081-606-70920. Thank you very much, my viewers. Keep yourself occupied. And remember, stay safe, stay home, and then practice all the guidelines given by the NCDC or the World Health Organization in general. Thank you very much.